In this lesson we'll learn one more way to integrate functions. So we know how to integrate this, and we can integrate the 2x to get x squared. We can integrate sine to get negative cosine. We have plus c. But now what happens if we have this and we could make something up, but whatever we get over here, if we take its derivative, it has to take us back to this. So we're going to run into a problem. Whatever we make up, whatever rule we make up here, and we get some antiderivative over here, once we take its derivative, it won't be this. So here's our challenge today. How do we deal with something like this? And the important characteristic of this function is that it is composite. We have an inside function and an outside function. So we're going to use substitution to deal with a composite integrand. So if we want to integrate this, here's a way to organize and also anticipate different types of functions that require different strategies. We're always going to use this column. We will only use this column if we have limits, if it's a definite integral, and we'll use this column if all of the x's don't disappear. So we usually will just say u is going to be the inside. U equals x squared. And then we want to find the differential of u, that's du, and the differential of x squared, which is the derivative times dx. Now we want to be able to substitute for dx, so we're going to isolate dx. Now we can substitute for x's in the integrand. We'll leave that for now. X squared is u. Dx is du over 2x. And hopefully all of the x's cancel and we're left with something, an integral that only has u in it. And now we can do the antiderivative of sine is negative cosine, and we know that u is x squared. Try that one. Pause the video and we'll say that u is the inside function. We'll find the differential. Solve for dx. And we don't know if we need this, and we definitely don't need this. This is only if, oops, I forgot this. This is only if we have limits. All right. X cubed is u. Dx is du over 3x squared. And then these divide to equal 1. So we have the integral of cosine of u du. And that's going to be sine u plus c sine of x cubed plus c because u equals x cubed. Alright, so here we just have to identify the inside function, and here's an outside, here's an inside, and let's just hope that cancels. So we'll have u, x, and u evaluated at some number at a limit. We're not going to use that column because we don't have limits. Hopefully we don't have to use this column. So u is the inside. The differential of u is 4x dx. And du over 4x is dx. So now we can substitute for dx. X u cubed du over 4x. So we substitute for dx. The x's cancel, and we're left with a 1/4. So we have 1/4 integral of u cubed, and that will be u to the 4th over 4 plus c, so 1/16 u to the 4th, but we know that u is 2x squared plus 1, and we're done. Alright, pause the video and try that one. So u is the inside, and du is 3x squared dx. Divide by 3x squared. We don't need this column. So we have x squared u squared. We replace this with u, and then replace dx with du over 3x squared. The x squared cancels, and we have 1/3 integral of u squared du. Add and divide. So we have 1/9 u cubed plus c, and u is x cubed minus 2. Now we have a definite integral, so we're going to have to use that third column. U is going to be the inside. And now we're going to evaluate u at the limits. So we have u equals 2x squared plus 1. Du is 4x dx. Du over 4x is dx. Since we have limits, these are x values, and when we substitute we have all u values. We want to have these entered as u values, so we need to find out u evaluated at 4 is going to be 2 times 4 squared plus 1. 33. And then we have u evaluated at 2 is 2 times 2 squared plus 1, 9. When we substitute, now we have 9 to 33. We want u values. Substitute. The x cancels. And we'll have 1/4 u to the 4th over 4 from 9 to 33. And we could take that out as a 1/16 and then just have 33 to the 4th minus 9 to the 4th. And a little mental math gives us 73, 710. Okay, pause the video and try that one. U evaluated at 2 and U evaluated at -1. We have x values and we want u values. So u evaluated at 2, we'll have 2 cubed minus 2, 8 minus 2, 6. Here we have -1 cubed minus 2. That's -1 minus 2 is -3. So substitute, and instead of an x value of -1, we want a u value of -3. Instead of an x value of 2, we want a u value of 6. And the inside is u. The differential of x is du over 3x squared. And the x squared cancels. So we have 1/3. 1/3, -3 to 6. U squared du. And that'll be u cubed over 3 from -3 to 6. You can take the 3 out, so that's 1/9. And then we have 6 cubed minus -3 cubed. And here we get 27. And that's the end of that lesson.